black screen. Silence. Then, a faint electric hum. Not loud. Not aggressive. Just controlled. Like something holding back impossible power. Now imagine standing trackside. No roaring engine. No fuel smoke. No vibration. And then, in less than 3 seconds, a machine silently tears past you faster than a fighter jet taking off. Blink. And it's already gone. This isn't Formula One. This isn't Tesla. This isn't even something built in Silicon Valley. This machine was created thousands of miles away, in a small African workshop, by a man most of the world ignored, Maxwell Chikumbutso. And what he built might be the most powerful electric race car ever conceived.
Not just fast.
Not just electric, but powerful enough to make veteran engineers question everything they thought they knew about physics. Because this car doesn't behave like an EV. It behaves like a glitch in reality. And tonight, we're breaking down exactly how he did it. Most electric race cars follow the same playbook. Bigger batteries, more motors, more cooling, more weight. It's a constant trade-off. Power versus efficiency.
Speed versus range.
Performance versus heat. For decades, engineers accepted this compromise as unavoidable. You want insane speed?
Fine.
But you pay for it with massive battery packs and overheating systems. That's just how EVs work. Or, at least, that's what everyone believed. Maxwell didn't. While the world kept stacking batteries like bricks, he asked a different question. What if the car didn't need to store all its energy first? What if it could generate power differently?
Smarter.
Lighter. Instant. And that single question changed everything. Inside his prototype, there wasn't the giant battery slab you'd expect. No half-ton power pack. No bulky modules filling the chassis. Instead, a compact, shockingly lightweight energy system. Small enough that engineers who first saw it reportedly thought, there's no way this can power a race car. But that's exactly what made it dangerous. Because less weight means faster acceleration, sharper handling, shorter braking, higher top speeds. In racing, weight is the enemy. And Maxwell's car showed up nearly hundreds of kilos lighter than anything comparable. It was like bringing a knife to a tank fight, except somehow the knife was faster. Then came the motors. Not one, not two, but multiple high-torque electric drives working independently. Each wheel receiving instant torque. No lag, no gear shifts, no delay, just raw, uninterrupted thrust. The moment the pedal moves, the car launches. Full torque at 0 RPM, like being kicked forward by a railgun. Test drivers described it as unnatural, because the body isn't prepared for acceleration without sound. Your brain expects noise, but there's only silence. So when the horizon suddenly starts stretching toward you, it feels like teleportation. And then came the test run. No big announcement, no flashy event, just a closed track, a few cameras, and skeptical engineers standing with crossed arms. They expected another overhyped prototype. Something that would look cool, move a little, then overheat. Instead, Maxwell strapped in. The lights blinked green. He pressed the pedal, and in that instant, the tires didn't scream. The engine didn't roar. There was just a sharp electric whine, and the car vanished down the straight like a bullet leaving a rifle. By the time anyone reacted, the speed gun had already flashed a number nobody expected to see on an electric platform. Some of the engineers actually checked the equipment because they thought it was broken. It wasn't. The car had just done something that shouldn't have been possible. And that's when they realized this wasn't just another EV project. This was something else entirely. Because hidden beneath the chassis, Maxwell wasn't using energy the way everyone else does. He was doing something different. Something unconventional. Something that, if true, could completely rewrite how electric race cars are built forever. And when the team opened the rear housing to inspect the core system, what they found made the entire pit lane go quiet. The rear housing lifted slowly. Metal still warm. Heat waves shimmering in the air. Engineers leaned in closer, expecting to see the usual chaos. Cables everywhere. Massive battery stacks. Cooling pipes. Liquid systems. The typical electric race car mess. But instead, there was space. Too much space. Where they expected a giant battery brick, there was a compact core unit barely the size of a carry-on suitcase.
Clean.
Minimal. Almost simple. One engineer actually laughed. Not because it was funny, because it didn't make sense. How is this powering the whole car? Another crouched lower, running his hand along the chassis floor. No heavy modules. No layered battery trays. Nothing that explained the kind of power they had just witnessed. And that's when the math started breaking their brains. Because power like that should require weight. Serious weight. But this machine felt light. Dangerously light. Like a fighter jet disguised as a family car. Maxwell didn't say much. He never does. While others pitch ideas with flashy slides and big promises, he just lets the machine speak. He tapped the side of the core housing.
Come.
Confident. Like a magician who already knows the trick worked. This, he reportedly said, isn't just storage. And that one sentence changed the entire room. Not storage? Then what was it? Because every EV on Earth depends on storage. Charge first. Use later. That's the rule. But what if the rule was wrong?
Think about it.
Traditional electric cars are basically giant batteries on wheels. You're hauling thousands of kilograms just to carry energy around. It's inefficient. It's slow. It's expensive. It's like carrying a swimming pool just because you might get thirsty. Maxwell's philosophy was different. Why carry everything when you can manage energy dynamically? Flow instead of stockpile. Use instead of hoard. Deliver power exactly when it's needed. Instantly. Which explains something the drivers noticed immediately. The car didn't fade. Most electric race cars get slower after a few laps. Heat builds up. Voltage drops. Performance dips. But Maxwell's prototype? Lap 1 felt identical to lap 10. Same launch. Same punch. Same brutality. No fatigue. Like the car wasn't draining at all. Like it was just feeding. Continuously. Then came the second test. This time they pushed harder. Full track. Full throttle. No limits. Cameras mounted inside the cockpit. You could see the driver's hands trembling slightly on the steering wheel. Not fear. Adrenaline. Because when he pressed the accelerator coming out of the final corner, the car didn't accelerate normally. It slingshot. The G-force shoved him back into the seat, so hard his helmet snapped against the headrest. Data later showed numbers that sounded fake. 0 to 100. In under 2 seconds. 0 to 200. Still climbing like it didn't care about air resistance. And the craziest part? No gear shifts. No turbo spool. No engine scream. Just one continuous surge. Like gravity had been turned off behind the car. Track officials watching from the pit wall just stared.
Some smiling.
Some confused. Some genuinely unsettled. Because this wasn't evolution. This felt like cheating physics. Word started spreading quietly. First engineers. Then investors. Then racing insiders. How is a small independent team doing this? How are they outperforming billion-dollar manufacturers? How is this coming from Zimbabwe? And that last question, that one carried weight. Because the world doesn't expect breakthrough tech from places it doesn't understand. But innovation doesn't care about geography. Genius doesn't check your passport. And Maxwell proved that brutally. While major corporations were stuck in meetings and committees, he was building,
Testing.
breaking things,
Rebuilding.
over and over. Until one day, the result was a machine that could outrun almost anything on the planet. But here's where things get even crazier. Because speed wasn't actually the most shocking part. Not the acceleration. Not the top speed.
Not even the lightweight design.
It was what happened after the run. When they checked the energy readings, everyone expected the pack to be nearly empty. After that kind of performance, it should have been drained.
Dead.
Finished. but the numbers on the monitor barely moved, like the car had only gone for a casual drive. Silence filled the garage. Someone recalibrated the instruments. Still the same reading. Another engineer whispered, "That's impossible, because if the car wasn't losing energy the way it should, then something else was happening. Something nobody there fully understood." And Maxwell just stood there, watching their faces, knowing exactly what they were starting to realize. Because if the system could scale, if it could be mass-produced, if this technology left the track and entered the real world, then electric racing wouldn't just change. The entire auto industry would have to rewrite its future. And that's when one of the engineers asked him the question everyone was thinking. "Maxwell, what exactly did you build?"
He paused.
"Not a battery car. An energy machine." The words didn't sound dramatic. No speech. No presentation. Just matter of fact, like he was describing a toaster. But the engineers standing there felt a chill. Because if that statement was true, then everything they thought they knew about electric vehicles was outdated. The garage lights flickered softly overhead. Someone killed the engine logs. The fan slowed, and for a second, it was completely silent. No roaring engine. No ticking metal. No smell of fuel. Just this sleek, black machine sitting there like it hadn't just embarrassed decades of engineering. That silence was unsettling, because gas cars scream their power. This one whispered it, and somehow, that made it scarier. Maxwell opened the rear casing further, not to show off, not to impress, but to explain. Inside, instead of one giant block, there were multiple compact modules, distributed, independent, each one capable of delivering bursts of insane output. Think less single battery, more like a network, like a brain, or a power grid. Energy moving intelligently, not just dumping everything at once. He explained it simply. Traditional EVs. Store, drain, recharge.
His system.
Capture, regulate, redeploy, repeat.
Continuously.
Which meant less heat, less waste, less dead weight, but way more usable power. It wasn't brute force. It was precision, like replacing a sledgehammer with a laser. That's when one of the racing analysts pulled up the thermal camera footage, and everyone leaned in. Because normally after a high-speed run, electric cars glow red-hot, motors cooking, wires overheating, battery temps spiking. But Maxwell's car? Cool blues, greens, barely stressed, like it had just jogged instead of sprinted a marathon. Which explains something even crazier. Durability. Because speed records are cool. But what wins races? Consistency. And this thing wasn't just fast. It could stay fast, lap after lap, after lap, while competitors slowly cooked themselves alive. A week later, they scheduled a closed test. No press, no cameras, just numbers. The kind of test where excuses die. 10 consecutive full-speed runs. No cooldown, no breaks, just punishment. By run 6, other EV prototypes would normally throttle themselves to protect the battery. Software limits kick in. Power drops. Performance collapses. But Maxwell's machine? Nothing. Same launch. Same violent torque. Same terrifying acceleration. Like time wasn't touching it. By run 9, one engineer muttered, "This doesn't behave like a car." And honestly, he was right. It behaved like a weapon. Now imagine you're a billion-dollar automaker hearing about this. You've spent decades optimizing batteries, factories, supply chains, charging networks, and suddenly, some independent inventor shows up with a system that needs fewer materials, less weight, less complexity, and delivers more power. It doesn't just threaten competition. It threatens business models. Because if you don't need giant battery packs anymore, what happens to the companies built around selling them? If charging becomes faster, or less frequent, what happens to infrastructure investments? This wasn't just a faster race car. It was a ripple. And ripples turn into waves. Back at the track, the driver took it out again just before sunset. Golden light bouncing off the carbon fiber. long shadows stretching across the asphalt. The kind of cinematic moment you'd see in a movie. He lined up, deep breath, foot down, and the car launched so hard it almost looked fake. Like the footage was sped up. Dust exploded behind it, tires screaming for grip. And within seconds, it was just a shrinking dot against the horizon.
Silent.
Violent. Unreal. People stopped talking. They just watched. Because deep down, everyone there knew they weren't just witnessing a prototype. They were witnessing the beginning of something. Something bigger than racing. Bigger than one inventor. Maybe even bigger than the auto industry itself. Because if this technology escaped the track, if it reached motorcycles, buses, trucks, planes, entire cities could move differently. Energy wouldn't feel scarce anymore. Performance wouldn't require compromise. And suddenly, the impossible would start feeling normal. But Maxwell wasn't celebrating. While everyone else stared at the speed charts, he was already sketching something new. Another design. Another improvement. Because to him, this wasn't the finish line. It was just proof. Proof that the old limits were never real. Just accepted. And the scariest part? If this was only version 1, if this was the prototype, then what he was building next, what he hadn't shown anyone yet, what was still locked inside that workshop back in Zimbabwe, might make this record-breaking machine look slow, might make today's race feel like a warm-up, might change the definition of electric power all over again. And somewhere in that quiet garage, bare frame, no paint, no branding, just raw carbon fiber ribs under harsh workshop lights. It didn't look like a car yet. It looked like a skeleton. Something unfinished. Something dangerous. The kind of machine that only exists before the world has a name for it. Tools lay scattered across the table. Oscilloscopes. Hand-drawn diagrams. Circuit boards stacked like playing cards. No giant corporate lab. No billion-dollar facility. Just a quiet workshop. And ideas that didn't follow the rules. Maxwell moved slowly around the frame, adjusting mounts by millimeters. Not centimeters. Millimeters. Because at this level, tiny differences become massive advantages. 1 kilogram saved here. 2% efficiency gained there. Suddenly becomes seconds on the track. And seconds win everything. Here's the part most people don't understand. Breakthroughs rarely look glamorous. They don't happen with fireworks and headlines. They happen like this. Late nights. Cold floors. One person solving problems everyone else accepted. While the world sleeps, someone is rewriting physics with a screwdriver. That's what made this story different. Because Maxwell wasn't trying to build the fastest EV. He was trying to remove the limits entirely.
Speed was just a side effect.
Weeks later, rumors started leaking. Quietly. Through mechanics. Through suppliers. Through whispers at test tracks. They're not just increasing power. They're reducing draw. They're barely using energy at all. Which sounded ridiculous. Until someone saw the new telemetry. The power curve wasn't spiking like normal cars. It was flat.
Steady. Controlled.
Like the car wasn't fighting resistance. It was gliding through it. And that's when one engineer described it perfectly. It's not accelerating harder. It's wasting less. That one sentence changed everything. Because maybe the future of speed wasn't more horsepower. Maybe it was less loss. Less heat. Less friction. Less dead weight. Which meant more of every electron actually doing useful work. It's not louder. Not flashier. Just smarter. Back on the track, they mounted fresh tires. No announcements. No crowd. Just data. Always data. The new chassis rolled out slowly. Lower stance. Wider track. More aggressive aero. It hugged the ground like it didn't trust the sky. Even standing still, it looked fast. Like a predator crouching before the chase. The driver climbed in. Helmet clicked. Gloves tight. Radio crackled. Ready when you are. Maxwell simply nodded. No speech. No countdown.
Just a small hand signal. Go.
The launch wasn't violent this time. It was smooth. Too smooth. Almost gentle. And somehow, that made it faster. Because there was zero wheel spin. Zero drama. Just perfect traction. Perfect transfer. Pure forward motion. Like the car had calculated the exact amount of force the asphalt could handle and used only that. Nothing wasted. By the first straight, it was already ahead of its previous record. By the second corner, the numbers on the monitor started looking unreal. Engineers double-checked. Then triple-checked. Because the delta time kept dropping. Lower. 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 This wasn't an improvement. This was a leap. Inside the cockpit, the driver later said something strange. He said it didn't feel fast. Not in the normal way. No shaking. No screaming motor. No chaos. It felt calm. Stable. Like the world was slowing down around him. Which is terrifying when you think about it. Because when 300 kilometers per hour feels calm, you're not driving a car anymore. You're piloting something else. Something closer to an aircraft than a vehicle. Back in the garage, the monitors flashed the final lap time. Silence again. Then someone whispered, "That's not possible." They compared it to professional race benchmarks. Gas supercars. Hybrid monsters. Factory-backed teams with unlimited budgets. And Maxwell's prototype? Faster. Not by a little. By enough to make people uncomfortable. Because now it wasn't just competitive. It was dominant. The kind of dominant that forces industries to react. The kind of dominant that makes rulebooks change. The kind of dominant that makes competitors nervous. And here's where things get bigger than racing. Because imagine this technology outside the track. Imagine ambulances with instant torque and no refueling delays. Imagine cargo trucks crossing entire countries with minimal energy loss. Imagine aircraft using lightweight power systems that don't depend on massive fuel loads. Imagine cities where charging stations aren't everywhere because you barely need them. That's when you realize this was never about building the world's most powerful electric race car. That was just the demonstration, the proof, the headline. The real mission was something else entirely. Something quieter, something bigger, redefining how energy itself moves. Late that night, after everyone left, the workshop lights were still on. Maxwell stood alone beside the new machine. Laptop open. Fresh schematics on the screen. Even after breaking records, he wasn't satisfied. Because to him, there was still inefficiency. Still weight. Still wasted potential. And if history had proven anything, it was this. Every time people thought he'd reached the limit, he quietly erased it. So while the world was busy arguing whether this car was real, whether it was hype, whether it was even possible, he was already designing the next evolution. Smaller core, higher output, even lighter frame, even less loss. A version that wouldn't just beat race cars, but embarrass them. And as the camera slowly pulls back, past the scattered tools, past the glowing monitors, past the silent, record-breaking machine cooling in the dark, we see something covered in a black cloth at the corner of the workshop.
Bigger.
Longer. More aggressive. Not the current car. Not the prototype. Something else. Something newer. Something nobody outside this room has seen yet. And Maxwell reaches for the cover and pauses for just a second. His hand rests on the fabric. For a moment, nothing moves. You can actually hear the room. The faint hum of a charger. Metal ticking as it cools. Wind brushing softly against the tin walls of the workshop. It feels less like a garage, more like the calm before a storm. Then, he pulls. The cover slides down in one smooth motion. And what's underneath doesn't look like a race car anymore.
Not really.
It's lower, longer, sharper. The cockpit almost centered like a fighter jet. Wheels tucked tight into sculpted aero tunnels. No unnecessary surfaces. No decorative curves. Every line has a job. Every edge slices air. It doesn't look designed. It looks engineered by survival. Like something built to escape gravity itself. If the first car was powerful, this one looks inevitable. like it was always meant to exist, like the future just arrived early. There are no giant vents, no bulky battery housings. In fact, it looks lighter than anything they've built before, which makes no sense, because lighter usually means weaker. But Maxwell doesn't design weak. He designs efficient, and efficient beats strong every single time. He opens the side panel. Inside, not more components.
Less.
Fewer cables. Fewer parts. Fewer failure points. Anyone expecting complexity would be disappointed. Because the scariest thing about it is how simple it looks. Like the system has been refined so much. There's nothing left to remove. Just the essentials. Like a skeleton stripped of fat. Pure function. Somewhere in the distance, thunder rolls. Or maybe it's just a truck passing. Hard to tell. But the atmosphere feels heavy. Because this isn't just iteration anymore. This is philosophy. While the world keeps stacking bigger batteries, Maxwell keeps shrinking the problem. While others add horsepower,
He deletes waste.
while they chase more, he builds smarter. It's almost unfair. Like he's playing chess, and everyone else is playing checkers. The next morning, only 2 people are invited to watch. No press. No sponsors. Just a driver. And one silent engineer with a tablet. The new machine rolls out slowly. Even the sound is different. Not a whine. Not a roar. Just this soft, controlled electric whisper. Like a breath. The driver circles at once. You can tell he's nervous. Not because it looks fragile, but because it looks too capable. Like it might outrun his reflexes.
He slides in.
Harness tight. Visor down. Systems green. The engineer mutters. Maxwell just nods again. Always the nod. Always calm. Like he already knows the outcome. The car lines up at the start. Sun barely rising. Track empty.
Cold air.
Perfect conditions. The kind racers dream about. 3, 2, 1. No tire smoke. No drama. It simply disappears forward. Like someone pressed fast forward on reality. By the time your brain registers movement, it's already halfway down the straight. The tablet starts screaming numbers. Acceleration curves that don't look human. Torque delivery so flat it's almost artificial. Zero hesitation. Zero drop. Just constant, relentless thrust. Like being pulled by gravity itself. And then something strange happens. The driver lifts off, not because the car hit its limit, but because he did. Later he says, "It felt like the car still had more, but I didn't." Let that sink in. Not machine limited. Human limited. That's when you know technology crossed a line. Because for the first time, the bottleneck isn't engineering. It's biology. Back in the pit, nobody cheers. Nobody celebrates. They just stare at the lap time. Because it's not just faster. It's absurd. The kind of number that makes people question their instruments. The kind of number that makes rule committees nervous. The kind of number that gets quietly banned before it ever races officially. Because if this competes, nothing else stands a chance. And racing hates inevitability. Maxwell closes the laptop. No smile. No victory pose. Just quiet focus. Because in his mind, this still isn't the end. It's never the end. It's just another step. Another proof that limits are usually habits, not laws. And as the sun climbs higher, casting long shadows across the track, the car sits there silently, cool, efficient, almost innocent looking, like it didn't just rewrite what electric power means. And somewhere beyond the fence, beyond the track, beyond racing itself, a bigger question starts forming. If this is what he can do with one car, in one workshop, with a tiny team, then what happens? When this technology scales, when factories adopt it, when cities use it, when planes, trains, for a long moment he just stands there. Quiet. Still. The track behind him empty now. Morning light pouring through the workshop windows. Dust floating in the air like tiny stars. The record-breaking machine cooling in the corner. Anyone else would celebrate. Call the press. Post the numbers. make noise. But Maxwell? He doesn't chase applause. He chases progress. He looks down at the blueprint, blank, waiting, because to him, every impossible breakthrough is just version 1. And version 1 is never enough. Here's the truth most people miss. The world thinks revolutions are loud. Explosions.
Headlines.
Crowds cheering. But real revolutions? They're quiet. They happen in rooms like this. With a pencil, a table, and one person stubborn enough to question everything. Speed wasn't the goal. Records weren't the goal. Even racing wasn't the goal. Those were just proof. Proof that energy doesn't have to be heavy. Proof that power doesn't have to be wasteful. Proof that innovation doesn't need billion-dollar labs. Just clarity and courage. Because what Maxwell really built wasn't just the world's most powerful electric race car. He built a new way of thinking. A system where efficiency beats excess. Where intelligence beats brute force. Where lighter beats larger. And once you see that, you can't unsee it. Suddenly, every traditional car feels outdated. Every massive battery feels unnecessary. Every old rule feels negotiable. Back on the track, the sun climbs higher. Birds crossing the sky. Wind sliding across empty asphalt. No crowd. No trophies. Just silence. The kind of silence after history quietly changes. The kind of silence before the rest of the world catches up. The car sits there like a sleeping animal.
Still.
Composed. Unreal. Not screaming for attention. Because it doesn't need to. It already proved everything. And maybe that's the most powerful part of this whole story. This didn't come from a global corporation. Not from Silicon Valley. Not from a billion-dollar automaker. It came from a small workshop in Zimbabwe, built by someone who simply refused to accept that's how it's always been done. And that's what makes it dangerous. Because if one person can rethink the rules, anyone can. Anywhere. So the next time someone tells you electric cars can't be lighter, can't be faster, can't outperform gas, can't break records, remember this moment. Remember that quiet garage. Remember the machine that moved like lightning without making a sound. Remember the engineer who didn't add more. He removed what wasn't needed and changed everything. Maxwell folds the blueprint, turns off the lights. The workshop fades into shadow. Only the outline of the car remains.
Low. Sharp. Silent.
Waiting. Not just a race car anymore, but a signal. A glimpse of what mobility could become. And as the door slowly closes,